Okay, are we back? Hello, Fee. Are you back?
Yeah, just sir. He's not back yet.
Okay, so we should take note so that so we all agree now. Do we agree what we have here now?
Yes, sir. We are good, but we are not seeing the screen, sir.
You're not seeing the screen. Okay. Okay, now. Okay, you are seeing it now. Can you see?
No.
Can you see now?
Yes, sir.
Yes, sir. Yes, sir.
So we all agree that what we have here is the correct thing now.
Yes, sir. Yes, sir.
Yes, sir.
Sorry, what's the correct thing now?
What we have on the screen now, what you are seeing on the screen
Okay.
is the right thing.
Hello, sir.
Yes.
Please,
Hello.
sir, I still want us to clarify. Sir, I would like us to clarify. Because
Okay.
I'm still, which is small letter L is equal to maximum length, capital letter L over 2.
Yes.
So it means that our maximum
effective
length, which is the capital letter L, equal to 2 times small letter L, which is the effective length.
Yes.
Okay. Yes.
So, and in the formula, sir, we
Yes.
have, you said it is the maximum length, which is the capital letter L.
Effective length. In the formula is
Effective length.
effective length that we have. In the formula, this formula in blue is effective length. Effective length.
All right. All right, sir.
Yes.
So find that the effective length is small L over 2.
Scholars will work well.
And we are not given the effective length. That is 2L, 2 and the bracket capital L.
What did you say? So
To
whatever.
find effective length,
Yeah. Yes.
effective length is original length over 2.
Yes.
And we are not given effective length.
We are not giving effective length. Yes.
So
We are not giving effective length. We are not even giving the maximum length.
Okay.
So look at.
Okay, is right. I thought we want to use that small L to be 2L.
Yeah, no. Okay, you can do it anyhow you think you want to do it. You get, you know that you can.
Sir, the thing is that, sir.
Yeah, you can. Yes.
It's better we are sure, sir. In the formula that has P subscript R, the L there, is it the effective length or the maximum length?
I have said this several times. The L we have here is effective length. If
sir,
it's effective length. What we
sir,
have is
if it's the effective length, sir.
Yes.
Then it means that once after getting our L,
that means okay. That means if it's effective length, Okay, very good. There are two ways. Look at this. Okay, let's do it this way. Very good. It's either let's leave the effective length to run, and the answer we're going to get is going to be in terms of effective length. Then we'll now multiply effective length by 2 to get our length. Is it not?
Exactly. Exactly, sir.
So there are two
Yes,
ways of doing it. So now you guys now should do it. This we have done it now using the maximum length, using what? Substituting for what we have here to get the maximum length. Abi? So what we have here is
sir.
Yes, sir.
Let's see. Oh. So what do we do now? Do you guys, okay, or should we do it together?
Sir, I think the way we did it is correct. But if you want to use that small a, that is when we're not going to use the previous one you raised.
Yes. And as you are the one that gave us that one, so we decided to follow you.
Yeah, I think, sir, it's
we
clear,
can
sir.
either do it, we can do it both ways.
What we have is correct.
What we have now. Even before.
Yes, it's correct, sir.
Okay, now what we have here is what? This is the maximum length, Abi?
Yes, sir. Yes, sir.
Yes.
Okay, now let's do something before we go, before this time lapse. Okay, you guys should stop. Can you, or let's do it together? Let's do it together. Let's see. Let's start. Let me copy. Okay, let me copy from here, and then see what we'll get at the end of the day. Abi, should we try?
All right, sir.
Should we do it together,
Yes,
or you go and do it individually?
Sir, we will do it individually. Next question, sir.
Okay. So do it individually and then come back. Okay, no, 16. A wholly cylindrical cast iron column of 150 is internal diameter, 15 mm thickness. So what's the external diameter now? Looking at this question here, what's the external diameter? Who can tell us what the external diameter is? Internal diameter is 150 cm.
150 mm.
150 mm. Thickness, you say one what?
180, sir.
180, good. 3 meter long and is hinged at one end and fixed at the other. Calculate the ratio of A, calculate the Euler's and Rankine's axial load. B, length at the critical load by Euler-Rankine formula will be equal. Okay. Do you understand what this question, this part B means? Length at which the critical load, let me adjust this. Length at which the critical load by Euler's or Rankine's formula will be equal. This one means what? Equate. Now, first thing first, look at this. According to Euler, is this column, is it a short or a medium column? Because you know, before you can do this B part, you know, B says what? Equate Euler to Rankine and then get the length. This one, so what column is it? Is this a short column or it's a long column? How do you determine if it's short or long? Slenderness ratio. What do we do in getting slenderness ratio? You know, do you remember? You've forgotten slenderness ratio. Ah, God. Okay, let's look at you guys should look at this thing. Look at the Look at the
Externalness
solution.
ratio, effective length over least lateral dimension.
Okay. Yeah.
That's effective length over radius of gyration.
Effective length over what? Radius of gyration. Okay. So, and if it is less than what? That is short. If it is greater than what is long. Oh, let's okay. You can remember that. Okay. Let's look at the solution together. Right? Are we good? Any confusion?
None so far.
Okay. Okay. We said external. This what I asked the other time, and this guy said 180. It was supposed to be this is already external diameter. So what we are looking for is what? Internal diameter. Yes. So internal diameter will be the opposite of what? Yes. So you list out the parameters that you have, calculate the ones that you can calculate before you get to the very good. This is Euler now. This is using Euler to say the first one says what? Use Euler to calculate the ratio. And look at this. Ratio means what? Ratio of the distance and this axial load. Divide Rankine by Euler. Right? This is you calculated the Euler here. So now you have to determine the parameters for the Rankine that you do not have. You do not have the area, so you calculate the area since it's circular. You do all these ones, get your radius of gyration, and then you come in here. Right? Are we good?
Yes, sir.
Okay, so now let's look at this. Let's look at the Euler's equation here. What we have here, is it correct? What we have, there's a long length, okay, this. And what we should have is hinged. Okay, what's the end condition? One side is hinged, the other side is free. So what is what are we going to multiply? What's the correction factor? Who can remember? Okay, one is spin, the other is fixed, 0.7, right? 0.7 L. Okay, this is where we are. So, okay. Something is wrong. We did not change this.
Yeah,
Are you guys following? Are you guys following?
yes, sir.
Sir, yes, sir.
So what is wrong here now? Someone should tell me what is wrong.
It should be 0.7 multiplied by 3,000.
Yes, this should be divide or multiply by 3,000.
More
Is in
Our length is 3,000. Multiply 3,000.
0.7
Yeah.
multiplied by 3,000, yes.
yes. 0.7 times 3,000.
Yes. Because don't let us forget, whatever we have, it is what?
2,100.
Okay, so let's go. So what do we have here? By the time we do all these ones, do everything here. What do we have here? Let's have the final answer. Let's have the final answer. Oh, this one is just mathematics. So, is it correct? 0.7 times 3,000 divided by this now, squared, everything. 0.7 times 3,123 divided by 37.50. Yes, times that's 56. 3,100 times 6.25. divided by what?
The denominator will be 0.035. That's 1 plus 0.
What are you saying now?
I'm still calculating.
Please do your calculation very well. Finn, let's take this together. Let's take it together. 0.7 times 3,000. What is the answer? It's 2,100 divided by 35, right? 35.50. What is that?
37.
Sorry, okay, 37.50. What's that? That's 56. Is it not? 56
Yes.
times 50. Yeah, 56 times 56. 3,136. Is that not?
56 times.
56. 56
Uh-huh.
squared. Are we following?
Yes.
Following,
Yes, sir.
Times.
Yes, sir. Yes, sir.
Times 6.25. That's 19,600 divided by 10,000. That's,
The answer is 1.96.
yes. Now, yes, that's true. So plus 1, that's going to be 2.96.
So divided by 2.96. Now,
So what's the final answer there now?
Okay. The answer divided by 1 plus 1.9.
97.
971.
Huh?
971.
no.
971 9303 divided by 2.96 now.
So we have
971.
Who is talking? What is the answer? 9719303 divided by 2.0. 971.
The answer there is 3283548.311.
Correct.
Okay. 32
8354.
548
8.31.
31 is okay. 31 is okay.
Okay, sir.
I can keep the limit.
Okay, so now this is for Rankine. So let's divide the Rankine by this, by Euler by this one now. So what do we have?
Sir, let's change
Yes.
the kilometer, sir.
Yes.
Let's change the kilometer.
Let's change to exactly. Okay. That's true. That's true. That's true. So by kilonewton, that was going to be what? Divided by 1,000, Abi.
Yes, sir.
That's going to be 3283.55.
3.15, yes, sir.
Yes. Okay.
0.5, yeah, 55.
Okay, so now divide the upper by the lower, let's say.
Okay, sir. 138.79 over 3283.
0.04.
0.04. 0.022.
No, 0.04 is okay. Two decimal places is
Okay,
fine.
so that's my place. That's 0.04.
Yes. So now, the B part, we are finished with the A part of the question now. The B part says, at what point, you see that the loads, the critical loads are different. Eh? Answer me. So
Yes,
now
sir.
the B part is now asking that at what length will you have the Rankine and the Euler the same? Do you get? If you guys know how to use Excel, who can use Excel very well? This thing, if you put it in Excel, it will be very good. Oh, why is this thing jumping up and down? Where? Okay. Let me tell you, if anybody, any of you, if you can know, if you can go and study Excel, know Excel very well. No. Not Excel of 1+1. Serious Excel. That alone can give you guys a very good job. Very good job. Very good job. So the B part. At what point will you have L? Same. So let's look at this. Let's look at this. Let's see what we can do here. Are we following? Are we following?
Yes, ma'am.
Yes, sir.
If we notice it, on the right-hand side, we have capital L. So that on this other side too, we'll have the same thing, right? So do not mix it. Do not have a small L on one side and a small and a capital L on the other side. You must have the same. Are we for? Should I just let me remove this unit so that to be clear, or it's fine like this?
Anyone,
Sir,
sir.
it's okay.
Is it okay with the units that you have? Since we don't have units on the other side, let's leave. Let's say this is. Let's just leave it the way it is here. EI, right? So we don't
Yes,
have good. So it's clear now. This. So let's open up this thing before we start fixing figures there. So how do we make sure that we'll bring all the L together? We have L on one side. Okay, let's open up this bracket. Let's open up this bracket here. How do we open up this bracket? Who can tell us now? Or will you do it as an assignment? Okay. Now, all of you are here listening. So I want you to look at it and then get back to me. Solve it. Open up this bracket. Open up this bracket here. I want you to open up this bracket. You guys should work it out. I hope you guys are working.
Yes, sir.
Okay.
What are we asked to do?
That stuff inside that bracket. That he said we should calculate input values and calculate this.
Is what you have done here, is it correct? That's what I say you should do.
Exactly.
Look at it and solve it.
So we may need to end the class very soon. Some people are going to the mall school.
Okay, no problem. Okay, so in that case, time is up. So we'll meet next time again. When exactly are we meeting, Fane?
Same time next week.
Yes, sir.
Thank you, sir.
Sir.
Next,
Sir.
yes.
The last equation.
Yes.
You wrote pi square EI. Is it not supposed to be 2 pi square?
Why are you saying 2 pi square? No. Why?
Because we used 2 pi square here.
Wait now. What's the end condition? It says what? One end is fixed, the other end is free. Abi?
Yes.
No, forget it. It's not 2 pi squared. Why are you saying 2 pi squared?
Because we are trying to compare. We are trying to compare the two Euler and Rankine. So I feel that since we use the formula for Euler as 2 pi square EI over L square before, so when comparing them also, I feel that we should also use the same formula.
Okay. No.
That's for comparing them in B.
Okay, this is the, okay. I said something. I said in this one, we are using this is the maximum length. So you don't need to compare. We are using the maximum length. It's still the same. We are not converting yet. It's the maximum length that we want to get. Look at the question. The question says what? Let's look at the question again. Length, okay. Length at which? Very good. Length at which the critical load of this will be equal.
All right.
Now, just use them straight. We are using the maximum. We're using the original length. So we're not converting anything. That's why we have the same. That's why I said before we start, I said this L is the same thing with this L on this side. At what point will the length be the same?
Okay, so
yes. It is when you want to, if you put 2 pi here, that means this L on the Rankine side, you have to convert it to. You get?
Yes, sir. Yes.
Yes, that's right. Not to complicate it. Whatever you do, you are still going to get the same thing. Whatever you do on this side must be on this side. So no, remove the L, use the maximum length here. When we get the maximum length, we can get the effective length. So let's do it this way. Right?
Yes.
Yes, sir.
Yes, sir.
Okay, so this is an assignment. So you guys should do it and then we'll meet next week. Next week, Friday is far. So when are we going to, what is going to be your CA now? What is going to be your CA? Okay. All right, you guys are still 14 class, right?
Yes, sir.
Okay, no problem. Exam is in May, so okay, we still have time. No problem. But meanwhile, are you busy next week?
Which time next week, sir?
You know your timetable now. Why are you asking me that now?
Oh, okay, sir. We have a test and a practical next week.
When?
I think
That's all.
the test is a Tuesday. The practical test is on a Tuesday. Practical was supposed to submit on the 28th, which is
Which is upper week.
no, it's not upper week.
Next week cannot be 28 now. What are you saying? It's 2 weeks. 28 is 2 weeks time. Look at this here. Today is 14.
Sorry. Next week we are very busy. We have series of tests.
You said that
Monday.
this week. You said that this week.
We have two tests on Thursday.
We have two tests. We have one test on Monday. Yeah, that's it.
Okay. Bye bye. Talk to you
Ah,
guys.
those are
Pizza.
Eh?
but when he has the money, we send it. His account is having issues right now. Sir,
Yes.
supposed to do your test on Friday.
No, we can't do test on Friday. This Friday.
Yeah, that's next week Friday.
Okay, no wahala. That will be 5 minutes.
No, sir.
Yeah?
No, sir.
Why?
No, sir. There is light issue in school everywhere.
Let's do this test and forget about it too.
So you don't want to do test?
Sir, give us.
Give you what?
Assignment, sir.
Sir, I don't know if the videos have been discussed, sir.
What videos?
Told him he'll
Videos of
send
the
it.
class, sir.
I told him he'll send me.
All right.
Oh, those
Yeah.
things are heavy. Oh.
Hi.
Yeah, said that convert it for that info.
Eh?
They will convert it for us, sir.
Okay.
Convert skinny. Now relationship.
All right now. See you guys next week.
Bye, sir.
Bye bye.
We love you, sir.
You don't love me. Go and love your girlfriend.
Oh God.
Okay, now no while. I'll see you guys next week.
Bye, sir.
Yeah, bye. Where is it? Has it ended? Huh? Hello? Okay, good. Good. What's today's class? God. One, video. That's two. That's three. Three. That's two. Four, that's one. Four, that's two. That's one. Two. Part one, verse one. Verse two, part one, verse part one, verse two. One, verse three.